Hey everyone, welcome back. Today we're doing day 18, queues and stacks. And like the name of this question suggests, these are two new data structures that we'll be exploring today. Queues and stacks are everywhere in our daily lives. So for example, the queue to an ice cream store. So notice that the first person that comes to the queue will be the first to get the ice cream. So what this means is queues are first in, first out collections. For stacks, it's the inverse. So let's say a stack of cards. The card that you're going to take from the top will be the last card that you put on top. So what this means is stacks are first in, last out collections. So we're using both queues and stacks here, in this case to check whether if a word, phrase, number, or other sequence of characters is a palindrome. A palindrome is a fancy word to describe that which reads the same back and forward. So to determine whether if a string is a palindrome, HackerRank has already suggested a nice way to do that with both a queue and a stack. So notice that what they're doing is they're taking every character in S, they put it in both the queue as well as the stack, and they do that for every single character in S. What they then do is start to dequeue every character from the queue as well as the stack, and they check whether if these two characters are the same. If it is really a palindrome, you will be able to iterate through the whole queue and stack, and that is true for every single character. If not, then it is not a palindrome. So for this question, HackerRank has already done the whole dance of pushing or enqueuing a character for every single character in S, and also popping every character in the queue and the stack, and checking if they are the same, otherwise return it as not a palindrome. But our job here is to implement this solution class that contains the stack and queue that HackerRank will be using. So in this case, for the solution in the constructor, we have to define two instance variables, one for stack and one for queue. The next thing that we will do is define the push, enqueue, pop, and dequeue methods that support the stack as well as the queue. So that's pretty much it for this question. Let's get started. So with that, let's first define the constructor. The constructor would take in nothing, as you see on line 11, but what it does is define the stack as well as the queue instance variable. And in this case, you might be wondering, how do we implement a stack and queue then? There's a few ways to go about it. You could use a linked list, you could use a list, but to keep things simple, I'll be starting off with a list first. So now, the next thing we have to do is to implement the push character method. This push character method takes in a character of type string, and in this case, it pushes that character onto the stack. So it's doing a mutation to the instance variable stack. So in this case, notice that it's complaining because this is an instance method. It was expecting a self keyword over there. So to push that character to the stack, all we have to do is to self.stack.append character. And just like that, we're done. What we are doing is we are taking that character and just putting it to the end of the stack, just like using the append method right here. So the next thing we'll do is define the enqueue character method that pushes that character to the queue instead. So let's do that. Let's define enqueue character. And in this case, similarly, this method will return nothing, but it will put the character at the end of the list as well, which is the queue. So that's pretty much it for the first two methods. Now we will be implementing pop character and dequeue character. So for pop character, in this case, this method doesn't take in anything, but it returns the last character inside this stack. So what we will do is self.stack.pop and return this. So this pop method removes an item at the back of the list, and that makes sense for a stack because imagine this to be a deck of cards. You're putting every card at the back of the list, and if you wish to remove the card from the top of the stack, all you have to do is pop the character to the right of this stack. So in this case, by doing pop on the list, we are supporting the stack behavior over here, which is to pop the last character that was inserted to the stack. Now we will do the queue character for the queue, and in this case, instead of popping from the back, in this case, we have to pop from the front because in the queue, you would want to remove the character that was first added to the queue. So to do that, fortunately, pop has this index parameter, and this specifies the index of the item that you want to remove. So to remove the first item in the list, all we have to do is specify 0 as the index. So that's pretty much it for this question. Let's run this code. This passes the sub-test cases and all the test cases. The next thing that you might be wondering is, okay, self.q.pop, you're popping the character at the first index, but doesn't that mean you need to move all the characters from index 1 and onwards one step forward? That's true. In fact, q.pop in this case, pop 0 in this case is really on. And that's because if you remove the first character, let's say you have a list of 100 characters inside this queue. If you pop the first character at index 0, then you have the job of shifting the character at index 1 to index 0, the character at index 2 to index 1, so on and so forth. You are making 99 movements of every single character forward. So this is actually very expensive. Using a list for a queue can be really expensive. So you might be wondering, okay, what other methods we can use to implement the queue then? So fortunately in Python, we can use a double-ended queue, and that is part of the collections library. So from collections, import double-ended queue. And this double-ended queue data structure is really implemented with a doubly-linked list. And what the double-ended queue data structure supports here is pop left and pop right operations. In other words, you can pop the characters in your double-ended linked list from the front or from the back in O1 time. There's no need for you to shift items back and forth in the linked list, even after removing an item. Unlike a list, you can also append left and you can also append right as well. So a double-ended queue is perfect for a queue implementation. So to use this, let's replace this with a double-ended queue. And in this case, the queue supports append operations as well. So doing deque.append, this puts the character at the right of this double-ended queue. But what we can do here for the deque operation, instead of doing pop, we can do pop left. Pop left is a method on this double-ended queue data structure, this object of type deque. So now this is now O1 because you're just removing the linked list node on the left of this double-ended doubly linked list. So that's pretty much it for the final optimization to this solution. So this passes all the test cases, and that's pretty much it for this question. So in summary, we learned 3 new data structures. We learned queues and stacks. We learned how queues are a first in, first out collection. Stacks are first in, last out collections. And how we can easily use a list for both the queues and the stacks implementation. However, we also noticed that using a list for a queue implementation can be very inefficient. To be specific, dequeuing a character is on because after removing a character at the front of the list, you have to shift all characters in that list one step forward. So that is on time complexity, where n is the size of your queue. So to optimize that, we use a doubly linked list for the queue implementation. Dequeuing a character from a queue is as simple as dequeuing the linked list node at the front of your double linked list. So this allows us to support deque character operation in O1 time complexity. And that's pretty much it for this question. If you find it useful, please give us a like and subscribe, and we will see you in the next video.